Yes, hello, thanks Musin for the introduction. So what I will talk about today is the data mesh as the concept, and which is has become pretty popular throughout the last couple of months already. So first of all, I think UNIQA is pretty well known in Austria, but maybe not so much in Germany and Switzerland. So I want to briefly tell you what we are doing. We are an insurance company. We are having about 21 million contracts. We are active in 18 markets. Austria is our core market, Czech Republic, Poland, a lot of Southeastern European markets and Eastern European markets. We have 21,000 customers, employees, and 15.5 million customers in those markets. So that's a little bit about that. Then who am I? So I'm the head of data, responsible for everything around data within UNIQA Insurance Group. Before that, I was working at A1, Austrian telco, and at Microsoft. And I wrote a couple of books. One of that was on cloud. The other one was on data science. And I'm speaking normally in pre-pandemic situations, which I don't know when we'll come back to a normal situation again, on different events, such as the London Tech Week and Chitex Dubai. If you want to reach out to me, just hit me up on LinkedIn, Twitter, or visit my blog. So that's how you can get in touch with me. Really funny, as I always pull up a picture of myself and then I let an algorithm predict it. The algorithm predicted it's a person in a green shirt, just as that it has to do something with data. So what will I talk about today? Today I will talk about data mesh, which is a design principle for data applications and how it's impacting machine learning and data science. I will not talk much about the concrete technology, because data mesh is a concept, how you deal with data, and it's a cultural change and not a technical implementation or technical problem and stuff like that. So basically, to set the scene, I normally ask which side you are on. It's pretty tough to get this number without people raising their hands. So either you are from a startup or a large corporation. I'm from a large corporation, so I cannot. We cannot start data on the green field. We have a lot of legacy and stuff like that, which we have to solve before. So that's what I want to talk about today, is how big corporations struggle with data, what issues we have around data, and why we are having those issues. This is my first part of the presentation before I come to the data mesh and how this will hopefully solve a lot of our problems. So let me jump into the different aspects why big corporations struggle with data. So first of all, it's about the distributed data ownership. We have different departments within a corporation, within a large corporation. We have different countries which are within the corporation. Large corporations acquire other companies, sell parts of their companies and stuff like that. This leads to a highly distributed data ownership. And once you start to harmonize your data models, once you start to harmonize all your data, you buy and you acquire new things, you create new units, and new data silos will get created. So we have a highly distributed data ownership within large corporations, and there is no easy way to get around it. Then we have, of course, a lot of legacy. So the insurance business has been around for a really long time, and it's not like that we created UNIQA 5 years ago. So we have some history, which is nice, but we also have legacy, which is maybe not so nice. So to deal with the legacy, it's a real big issue when we come and talk about data. And this all leads to one problem, which is the siloed data. Siloed data in terms of we have data in this department and there's data in that department. And often it's not possible to have one common view on the data which we want to talk about, which we want to analyze. We don't know the quality of the data which we have and stuff like that. So what I'm not going to talk about today is about machine learning or data science, which is obviously the fun part. What I'm talking about today is about the challenging parts. Why are big corporations struggling with the fundamentals, the data management, and how is it possible to make machine learning eventually work? Because this is our end goal, to have data science, machine learning, and deep learning, and all the fancy stuff in play. So let's do some history lessons. How do we get there? How do we get to this point when data is becoming so complex to deal with in corporations? So when we talk about data, we saw a couple of evolutions. The first evolution was the data warehouse. That's the first time that we had a structured approach on working with data. And the goal was to have all data in one place, one format for analytical purposes, and to have the data harmonized. It was a really nice goal to achieve, to have all the data harmonized in one place for analytical purposes, but it failed. Why did it fail? It was simply too expensive. It didn't scale well. It was not suitable for other data formats. So we couldn't bring in data formats which were outside of SQL. So whenever we worked with the data warehouse, you needed to go pretty deep into SQL, and it was highly relational. Even though in the last 5 to 10 years, data warehouse providers integrated new data formats and stuff like that, but still it's heavily focused still on relational data. And this simply was very expensive. So we saw another evolution, which is called the data lake. It's coming out of the approach of Google and the like. What happened there? We had another try to basically come across the challenges we had with the data warehouse. We wanted to have it way cheaper at lower cost. We wanted to add much more flexibility by adding no SQL and by adding new data formats. We wanted to have a higher scale because we needed to deal with big data. So we tried it with the data lake. And here is the question, why did this fail now? There's a couple of items why it didn't work out well. It had a terrible governance, and it was almost impossible to harmonize and centralize all the data. So when you have a large corporation, you have specific resources which you can use and teams which you can use to ingest data. And from a cost perspective and from a resource perspective, it's impossible to harmonize all the data. And until a specific department gets their data ingested into the data lake, probably takes months or even years. And this leads to them creating another silo. So we were just running after the silos and you could never harmonize it. And all data lake projects I saw is, yeah, we got some data into it, but never the full set of data. So the evolution of the data lake also was not the right approach for us. So what happened? What is the weakest point of all the two evolutions we saw? That what I stated at the very beginning, that data is always decentralized, distributed data ownership, and that data always belongs to the business. So this thing we never tackled. We took a centralized system to solve a decentralized problem. And can you see the problems we created? The problem in here, we have decentral, something is decentral, the data, and we want to put it and pull it into a centralized system. And this simply does not work because business eventually owns the data and works with the data, and all the value, whenever we talk about creating value out of data, is being generated in the business, not in an IT department. So this is the key issue. The key issue is how we dealt with data. It's a cultural aspect. So now what we see is a third evolution, the data mesh, which is about not just accepting the distributed and decentralized manner of the data, but embracing this one. And as I stated at the very beginning of my talk, the data mesh is not something which you can implement. It's not a software which you can install, a software which you can launch in the cloud. It's not a software. That's a cultural approach on how to deal with data. There's always a software underneath it, of course, and the software stacks which we were dealing like in the past, relational databases, NoSQL databases, file storages, they're still valid. They're not being replaced by that. The data mesh is just by dealing different with data. And this is what I will show you now in the second part of my presentation, how one company can change how to deal with data. So first, I want to address what will the data mesh solve. And as I was talking in the first part of my presentation, what were the key issues when we handle data at present? We're not focusing on the business. So we had a business problem to solve with data science, and we created a technical problem out of that with months and years of implementation effort. The focus was too much on the ETL process rather than on the business process. And we were focused too much on building a monolithic platform, such as the data lake or the data warehouse, which again took months to implement and to run them perfect. So with the data mesh, we want to come across those pain points. Pain point number one, which is not focusing on the business. So whenever the IT departments are confronted with a business problem, the way how they normally try to solve a business problem is by creating some technology out of that. So what we did is with all the data warehouse and data lake implementations, we had a business problem to solve and created a technical problem, because eventually all those implementations were critical in timeline and challenging to solve. And what we also did is we pulled the data scientists and the engineers into silos and hyper-specialized teams, and they had no clear view on what's going on in the business, and they could not answer the business questions eventually. They are not placed well in the centralized IT department. The other thing is that data happens and stays and should be in the business. It's very domain-driven. Marketing knows best about their marketing data. Sales knows best about their sales customer data, and so on and so forth. If you're talking about a telco, the network department knows best why network data is produced the way it is produced. So pulling this somewhere else doesn't make sense. The data per se is generated in the business domains and used in the business domain. So it doesn't make sense to pull this data somewhere. Then we were focusing too much on the ETL processes, where the applications are domain-oriented and the data was rather oriented on the ETL process. So we were breaking this, and we were focusing too much on the ingest process rather than focusing on the business problem again. And the third point, which I stated, the building of a monolithic platform, which takes far too long to implement, and it never pays off, because in the meantime, the technology changes again. So the recommendation here and the sidekick is to stop building the complex technology, because we already have it solved somewhere. It's available in the public cloud with serverless solutions. So what are the building blocks of the data mesh platform? So we have four key building blocks, where the first one, data, is very obvious because we are talking about data. Then the other three are the distributed domain architecture, which we'll all talk about later, then the self-serve platform design, and the product thinking. The later three one I will now discuss a bit more in detail. Data, I think that's very obvious, so I will skip that one. So when we talk about the distributed domain-driven architecture, basically the goal here is to build everything on the microservices architecture. So to build the smallest solution possible, and to build the least complex solution for solving a business problem with data. The data services which we built here in this context are all built with the architectural quantum. We'll talk about this later on, and there is books written about that, about microservices and the architectural quantum. So I would recommend you digging deeper if you want to. And very important here is that we build all data services for and to the domain. If you're talking about insurance, we build data services for the claims domain, for the fraud domain, and so on and so forth. And the ownership, very important, the ownership of the data is in the business. The use case teams work either within the business or really close with the business. So there is no process of, let's define the solution which we want to have, then throw it over the fence to some externals or to an internal IT department and wait until the implementation is done. That's not how we deal with data. It's owned in the business. The use case teams work closely and or within the business and deliver from that aspect. So in a nutshell, what is the architectural quantum and how will it solve our data aspects here? It's the statement is that we use the simplest and easiest architecture possible for our data workloads. That the architecture is not built for serving a complex monolithic system, but that we have a domain demand which we want to foster and solve. Data is domain driven and source oriented. So we work on the domain and with the domain of the data. And the second, or actually third part of the data mesh concept is the self-serve platform design. I do not focus on the infrastructure because it's already solved. We either use software as a service or platform as a service. Please don't use infrastructure. It's not solving any problems. We focus on solving the data problems. We do not focus on creating a monolithic system. We rather use storage services, which are platform as a service, where we have all the replica included, where we have redundancy, failover, and stuff like that, like using S3, other cloud storages such as Azure Data Lake Store, rather than creating an HDFS-based system. Plus, we use pre-built platforms in the cloud, such as Azure Synapse, AWS Redshift, or any other services like Google BigQuery, because they already have a platform as a service in place and built in, and we don't need to care much about setting and running the infrastructure again. So that's self-serve platform design. Plus, what comes on top there is that we work heavily on automation and CI/CD pipelines. We always need to automate what we did manually the other day. And last but not least, we are talking about data as a product. This basically means that we should treat our data with high quality, like the quality we treat our products with. And data per se is the fuel we have for digitalization. So it should just be necessary to have data quality and stuff like that in place. It should be also offered, data products within the company should be offered to other business units. And we want to make sure that we have specific quality in place. Whenever you offer something to another business unit, you should offer it with a high quality approach. So what is necessary in order to build data as a product? There is one clear thing, that it only works well with data governance. Without that, we are lost. So data governance is the key aspect for data as a product. And therefore, what we need for data as a product is that we have the discoverability via data catalogs, so that we need to understand what data is within our data product, within our data meshes, that we have each mesh addressable via an API, each data product addressable via an API, that you have service levels, that your data should be trustworthy, that you have self-description about your data, so that you have metadata, the data about the data in place. We need to set specific standards so that we stay interoperable between the data we offer within our company. We need to make sure that the data is secure, that we only give access to those people that really have the right to access it based on a need to know principle. And we need to build some kind of distributed data marts where we have different technologies fostering one data product. So there will not be one technology fostering all the data products, but we have different technologies in the future fostering different data products. So we take the best technology for the business case, and those must be interconnectable together. So last but not least, I want to ask the question, the radical question: will the data mesh solve all our problems now which we have with data? And here, unfortunately, I have to tell you, definitely not, but it will make a lot of problems gone and a lot of things easier in our lives when we work with data. So that's it about the data mesh. And now I would kick off the discussion and also have a look at the questions which were raised. Thanks.
Thank you so much. Thanks a lot for taking time this much. Now I give Alice a microphone to introduce herself, because you don't know her, and she can raise her own question. 1 second. Alice Vaskova, can you start, please?
Yes, sorry, I always need to unmute. Look, this is rather a technical aspect of data and analytics. Can you explain from your view the difference between data mesh and data fabric? And how you reflected on it, and what's your experience with it? Thank you.
Alice, I think what you're referring to is the data fabric, which is pushed by Gartner, right?
Yeah,
This is,
Yeah.
I mean, they are very similar to each other. Both of them foster the digital, the distributed aspects of data. I think it's both from the concept are very, very similar. It's just like will either the one concept or the other concept make the race? And I do believe that we will not have in companies the 100% clear data mesh implementation or the 100% clear data fabric implementation, because we will always adjust it to how it's being used within a company. But I would see the data fabric is a very similar thing to the data mesh, just with a different wording, maybe some slight difference in the how it's being called. And Gartner is definitely pushing their standard, of course, because it gives them benefits in selling their service again. So just as data mesh is being pushed by ThoughtWorks, so very similar. The approach is, I would say, roughly the same.
Okay, thank you.
And it's different wordings for that.
Thanks a lot to both of you. I have a lot of questions. Daria from CNA. Daria, again, microphone to Daria. Go ahead, Daria.
Hi, can you hear me?
Sure.
Ah, right, great. So my question comes more from a organizational change that is needed to implement a data mesh. In your experience, how did the, let's say, skill or talent that it's needed for kind of taking the ownership in a business, how did that affect or got affected through data mesh?
So first of all, we are in the middle of the progress. So we are transforming towards the data mesh. We are not there, I would say. But it's very difficult to answer because there are some parts of the company where the people have great skills on using data. And then we have places within a company where the skills are maybe not so good. So basically, of course, skills are being shifted to the business because the business needs to be better in dealing with data. However, there are always people in most business units, there are people being good in dealing with data, either from an SQL perspective, from a data science perspective. But this is something which we are addressing from the skill management or from the knowledge management now, because I'm working in a group function reporting to the board. And we have definitely this goal next year to improve the skills to make skill management. This is something which you have to tackle in the company. The skill management is highly important in order to solve that. So we need to ensure that the skills dealing with data need to be available in the business. The good thing is that we do not talk about the complexity we used to talk about prior, because you needed to implement data warehouse or data lakes, because this is being solved with the data mesh, because you focus on not on the platforms themselves. So this is basically skill management is critical to this transformation. Okay.
Thanks a lot. Last question. It was Dario from CNA. Now, Martin, last question shortly, please. Thanks.
Hey, Mario. Quick question. So I think over the last couple of years, customer 360-degree view was one of the most important topics that many companies, not only insurance companies, raised. How would you realize this in a decentralized data mesh? Because we have multiple domains adding to the bigger picture.
Yeah, there are customer 360 is always a complex thing. That's I think the first thing which we need to agree on. So building customer 360 is never an easy thing. I think the good thing about the data mesh is that you only need to agree on a couple of core attributes within customer 360. So you need to have a unique customer identifier, and then you need to ensure that you have a couple of unique things stored somewhere centrally about the customer, and then once they plug into this UID, the unique identifier, you can work on this approach that you have the extensibility of the data, customer 360 data set. However, there must be a central governance body that says, okay, what's coming into customer 360, so that you don't have zip code on the one data set, and then you have PLZ, which is the Austrian Germanized version of it. In the other data set, both are the same, but with different namings. So you need to have a centralized data domain architect that's saying, okay, this is coming in, but then give the possibility to the departments to adjust the data model. So our approach is to have a kind of a repository setup. Like when you're in software development, you have this concept of inheritance where you can extend your base class, and this is what we are working towards, so that we have this extensibility approach in the data set, but with a clear governance from the group.
So does this mean you still have sort of a golden source that you refer to for specific details for the customer?
Yes, but of course this should be as lean as possible.
Yeah.
Thanks a lot. So I know I took 1 minute from Mario from TigerGraph, but because it's the same name like you, Mario, I said no problem. We can steal 1 minute from him. Thanks a lot, Mario from UNIQA. You can switch off the camera.